All right, kia ora everyone. Let's start our lesson, or sorry, I should say our first lesson for week number 6 of our lockdown. So there's only going to be 2 lessons for week number 6. I want to give you guys plenty of time to process this new information, and I've also included a CPR quiz, so that's why there's only 2 content lessons for this week. And in fact, we are starting a whole new topic with this week. So I'll also walk through the assessment as well, just to get you guys to know what to expect. So finding out today is we are defining the key vocab word for oxidation. There's lots of vocabulary with this topic. You need to make sure you're using it properly. And the other thing we're going to be doing is processing how to identify the oxidation and reduction reactions in some real simple equations. These will get more complex next week, but we'll just start with the easy stuff to begin with, just to get you guys used to it. There are obviously resources from last year. You guys are welcome to look at it, but obviously I'm adapting it quite a bit this year because you're doing this topic during lockdown. For my class, I know you normally get a booklet, and I'll give you guys your booklet when we are back. So just be mindful that while you're watching this video, you might want to write some notes on a piece of paper for the time being. But do keep in mind these PowerPoints are online. You're welcome to print them out if you want. You don't have to worry about copying everything down. I think it's probably more important that you write down some of the stuff that I'm explaining, and I will point out when I think it's probably a good idea to pause the video and write some stuff down. All right, so first off, let's start with the assessment and give you some information. So this is Chem 2.7, which is Redox is the material that it's going to be covering. Redox is the shorthand name for oxidation and reduction reactions. This one is an internal with a small practical component, but the practical component is basically just the same as the other 2 theory questions. The only difference is that you have to do the practical to get your observations, whereas in the other 2 questions, we will give you the observations. Put a little asterisk next to it, though, because I am not sure this year if we're going to be doing the practical or if we'll just give you guys observation theory-based questions just to kind of make it a little bit easier for you. But basically for the assessment, you get 3 questions, and the grade you'll be marked out of each question, achieved, merit, or excellence, or not achieved, and then the majority that you get at that grade is going to be your overall grade. So if you get 2 merits and an excellence, then you're going to be getting a merit overall. This one's a lot easier than the other 2 internals you've done. There's no write-up component to it, and it's going to be much, much shorter. And in fact, we'll go through this material rather quickly because it's not a whole lot to this assessment. It's basically an equation-based assessment, so you're just balancing equations and using vocabulary, and I will walk you through basically what to expect with this assessment, but it's a pretty easy, straightforward one. The main thing is to watch for silly mistakes. This one is only worth 3 credits. And I would want to also add that the formative and summative dates are to be announced. I'm not really sure how this lockdown is going to last and how our calendar is going to be affected. I think the news reported today that the end of year exams have been pushed back 2 weeks, and I'm not sure if that's going to then affect anything that we're doing when it comes to our school holidays or when our mock exams will be. Just keep in mind we won't assess you until you guys are ready. But there will be a formative, so you guys can get some practice and some feedback, and obviously a summative. So here's our current timeline. Week number 6 this week, I just want to cover redox vocabulary, simple equations, and oxidation numbers with you guys. That's basically all introductory stuff to redox. If we're still in lockdown, or even when we're back at school, we're probably going to spend week 7 looking at oxidation numbers and equations, and then looking at balancing those complex equations. Week number 8, then, I have planned to do information on the assessment, so that way you know basically what the guidelines for the assessment is very specifically, and you guys basically have lots of time to practice it. I basically want to walk through and show you guys the template in which you are going to be doing your assessment on, and also how the stuff from the previous weeks and the content you've learned is going to tie into the assessment and give you real clear guidelines of achieve, merit, and excellence. So do keep that in mind when you're learning this, or do keep that in mind that I'm not going to be talking about the assessment till the very end. Week 9 and week 10, I'm not sure what we're going to be doing yet. Like I said, they haven't really announced how things are going to look, but this is the rough guideline of how things are going to break down, at least for learning this Redox material. And then, yeah, don't know what we're going to do after this. Anyway, I want to show you guys some of the Redox assessment just so you kind of have an idea of what to expect. What I have here is the resource sheet that we will give you on the assessment. Now, some things to note about this resource sheet. Oh, yes. This is the resource sheet that you'll get on the assessment. I want you guys to get used to start using it, just so that way you know how to use it. You're going to get the exact same one when you do both the formative and the summative. But we probably won't start using this until a few weeks later. So the first thing that I want you guys to keep in mind is that we're going to be giving you a list of all the species and all the colors of the various species. So you don't have to memorize the colors or anything like that. It's going to be important that you know this stuff because with the observations, you're going to be able to identify what species are there and have reacted. So that's why you'll need this list of information. And also part of this assessment I'm looking for is making sure you've tied in your observations with the specific chemical species that's involved. That's really important because we need to be able to explain what we are seeing. It's very similar to the ion identification assessment in that sense, where you're making annotations of what color things are, what states there are, things like that. The other thing that we're going to be doing is talking about redox reactions and their products. So think about the reactants and their products and their pairs. This is the list then, if you guys notice from this side to this side, that we started taking all their species and we're showing their relationship to each other. And that's the redox pair. Something that I want to note from the beginning, and we'll see it more when we actually start using this resource sheet, is that the forward reaction is always showing the reduction reaction. You guys don't know what reduction is yet, but you will at the end of this lesson. So everything going forward is showing the reduction version, and everything going in reverse is showing the oxidation section. What is going to happen on the assessment then is I'm going to give you two reactants. I'm going to give you an observation. You have to then figure out, okay, what is this reactant becoming, et cetera, et cetera. You have to keep in mind, though, that obviously with things like ionic compounds, there's two things there, and I'm mixing, say, for example, one ionic compound with another, and I need to figure out which are the active components. So using those colors is going to be really important, and then once I figure out what the active component is, I can find it on this list. Be mindful on the assessment, you're going to grab something from the left-hand side of the list going right, and something from the right-hand side of the list going left. But again, we will do specific examples like this so you can see how to use the resource sheet. It's just some beginning things to kind of keep in mind. This is going to be the template that you're going to be writing your answers on, and like I said previously, observation is going to be really, really important for this assessment. Don't worry, in that week 8, I will show you how to fill this in and take what you have learned and answer the assessment. So observations. With the observations, that's going to be a achieved level requirement that you do your identifications. Oh, I didn't have anything else written down. Then what you're going to need to do is justify what you are seeing. So you need to figure out what the oxidant is, the reductant is. You need to figure out the reactant going to the product. You also need to identify what type of reaction. Is it oxidation or reduction? And identify what the oxidant is. So if this is talking about an oxidant, then the reactant is what I'm putting into those answers right there. That identification process is, again, going to be an achieved requirement. You will need to justify how you know it's an oxidant and how you know it's a reductant. And again, I'll show you guys how to do that later. But that justification is what's going to get you up to the merit level. Merit excellence level, I should say. Equations are also going to be important. You're only going to be doing symbolic equations. The half equations are going to be merit, and then the full balanced equation combining the oxidation and reduction reaction will be an excellence point. Again, I will show you what this looks like when we're actually filling out this template in week number 8, but just to get you guys kind of thinking about what's to come. The other thing I'll give you when we're back in class, but is on the website, is our checklist. And as always, it's just going to give you a list of things that we are covering, and then a list for you guys to tick off when you feel ready and you're studying. On the bottom of that checklist, I'm also going to put the assessment requirements so you guys can clearly see what the A, M, or E requirements are. I will start referring to them when I'm teaching, but we really won't dive into it until about week 8. Yeah, and like I said, all these things are going to be uploaded to Google Classrooms yet, but I will be giving you guys hard copies as well. Resource sheet, reporting template, and then the checklist. All right, so let's move on then to today's material now that we've covered the assessment. On our checklist, we're looking at number 7, being able to use that redox vocabulary. So you guys have seen some redox reactions before. This is kind of a refresher of it. Last year, you guys did a chemical reactions internal, and I want to show you guys some ones that were redox reactions so you guys are aware of them. The vast majority of reactions that you will interact with are actually redox reactions. So you might have burnt some copper in a Bunsen burner and noticed some green light coming off. That is an example of a redox one. We often do the magnesium stripped into acid, such as hydrochloric acid, and it releases those hydrogen bubbles. That, and also the pop tests you do, where you basically burn the hydrogen gas and oxygen, is another redox reaction. The displacement reactions that you learned last year, for example, the zinc with the copper sulfate and the the zinc displacing the copper, that again is also another example of a redox reaction. And I'll revisit these later once you guys know some more content, just to show you how they are. So first, let's go through the history of redox. It's really interesting to hear this and also kind of know what we previously thought and how they've adapted the definition. So the first thing that people noticed was when there were chemical reactions and they weighed the substance before and after that reaction, they noticed that the mass was changing, and it was changing in reference to the oxygen atom. And so they originally defined redox as the addition of oxygen to an element or compound. That's the oxidation. They also realized that in some instances that oxygen can be removed from a compound, and so they referred to that then being as reduction. So the historical definitions of redox is referring to basically the addition or removal of oxygen. A good example of this would be burning any sort of fuels in oxygen. The 2 examples that I had earlier, the combustion reactions, forming, metal oxide or forming water. Those are all examples of the older definition of redox. So traditionally, then it expanded to understanding that redox reaction could also involve the transfer of hydrogen. So that added to, like I said, what we know about redox, and redox is just a short way of saying reduction and oxidation. However, there are a lot of chemical reactions that don't involve the oxygen and the hydrogen, and so once again, this definition needed to change and adapt with what we understand. Once we understood more about the atomic structure, that also helped us out. So what they eventually discovered is that redox reactions involve the transfer of electrons, and that's why I'm saying most of the reactions that we're talking about involve some transfer of electrons. So for summary, these are all the categories then of what would be classified as oxidation. So loss of electrons, loss of hydrogen, or gain of oxygen would all be considered an oxidation reaction. With a reduction reaction, it is the gain of the electrons, the gain of hydrogen, or the loss of oxygen that is the reduction. These obviously have to happen in a pair. So if something is losing electrons, the other half of the reaction must be gaining the electrons. Same thing with the hydrogen and the oxygen, because we can't create or destroy matter. So 2 little mnemonics to help you remember which one's which. I highly suggest that you write them down on the assessment, because it's very easy to confuse these terminologies. So loss of electrons is known as oxidation, and gain of electrons is known as reduction. So you can think about it as Leo the lion says grr, but they put Mufasa down there, so there you go, a Leo. So Leo says GR, loss of electrons, oxidation, gain of electrons, reduction. The other one that I see people use is oil rig. So oil oxidation is loss of electrons, reduction is gain of electrons. So any of those two mnemonics, that'll help you remember your terminology. Cool. So here is an example of a chemical reaction. I would suggest, actually I should explain to you guys, anything that is in red text on the PowerPoint, I do want you to copy into some written notes, just so that you can remember it. So make sure you copy down this equation. You can pause it at the end of my explanation or pause it anywhere in this video so you have a chance to write this down. But this is an example of a half equation. I have the magnesium metal losing 2 electrons to become magnesium the ion. And you guys have seen this last year when we were talking about the formation of ions and stability, because we know that we're trying to reach that octet rule. Now, when I'm looking at this equation, I notice that the electrons are on the product side of it. So since it's on the product side, this magnesium in the elemental form has lost 2 electrons. It has lost 2 electrons to form the positive 2 ion. Again, this is terminology I'm hoping you guys remember from last year. And again, I want you guys to make an arrow and just write that 2 electrons on the product side represent a loss of electrons. So we think loss of electrons, we think Leo, so this is an example of an oxidation reaction. And so we say that the magnesium was oxidized and it's forming the magnesium 2 ion. So again, lots of just defining with the new vocabulary. Here's the second half of the equation. So this one is the hydrogen ions. So basically, with my reactions, I'm thinking about that example of putting the magnesium into metal, because you know that's a redox reaction, and this is the equation for it, actually. So I see that hydrogen 2 ions, if I am gaining electrons, I form the hydrogen element. We can note that it is balanced. There are 2 hydrogens on this side, there's 2 in the molecule, and each hydrogen is gaining 1 electron. I can see that the electrons are on the reactant side of the equation, and so it's being added to my reactant. So hydrogen, the ion over here, has gained electrons. So I think GR, for Leo, the line says GR. GR is a reduction reaction. And then when I'm referring to what's happening, I would say the hydrogen ion was reduced and we are forming the hydrogen molecule. So those are my 2 sets of vocabulary. Now, when we are looking at this redox reaction, we have to have one reaction that's always oxidation and one reaction that's always reduction reaction. And the reason being is that we cannot create or destroy matter. So the electrons that are lost in the oxidation reactions need to go somewhere, and that's going to be the reduction reaction. Same thing if you want to think about it on the flip side. For the reduction reaction to occur, it needs electrons, and the electrons are coming from the oxidation reaction. So you should always expect to see transfer of electrons. You should always expect to see those electrons being balanced on both sides of the equation, and you should always see, for one equation, the electrons on the product side, and on the other reaction, the electrons on the reactant side, because they're going to need to cancel out. So here's where the vocabulary gets a little bit difficult and weird. So when I refer to magnesium, I refer to it as being a reductant. And the reason why is because it is reducing the hydrogen ion. So this terminology here is coming from whatever this reagent is doing to the other half of the equation. So that's why, even though this is an oxidation reaction, I refer to the magnesium as a reductant. So then when we're thinking about the hydrogen ion, this one is going to be known as an oxidant because it is oxidizing the magnesium. So just be mindful that the vocabulary switches at this point. I want to make sure you guys get that right and don't do something silly and have the whole thing backwards. So do be careful with that because we often refer to things as being reductant and oxidant, and on the assessment as well, we're going to ask you to identify the oxidant and the reductant. Cool. So now what I want to do is move on to my OneNote so I can show you guys how to use that vocabulary and how to balance these equations. So this is the second half, kind of the simple equations that we're looking at. So let me pull that up. I might make that a little smaller so it's not in our way. And I'm going to get my pen and start writing. Cool, and let's do some drawing. So, first thing I want to do when I'm looking at all these equations, I'm obviously putting them in a pair, and they're all in their redox pair, so all of these equations can't exist because I have electrons on the opposite side. Personally, what I like to do when I'm doing equations is I like to line up my arrows so that way it's really clear what's the reactant side and what's the product side. It's just to help keep things tidy. You don't need to, but I find you're less likely to make a mistake that way. So in my first reaction here, I see magnesium. I see it's going to the magnesium 2 ion, and I have my electrons on the product side. So my electrons have been lost, and I know that there's going to be 2 electrons lost because I can see that there's a positive 2 now. So if I'm going from to a positive 2 charge, I must have lost 2 electrons in that process. In the bottom reaction, I see that the chlorine is a 2 and the chloride ion is a 1, so I'm just going to put a 2 in front to balance it. Balancing is going to be really important. And then I'm looking to see where my electrons are. So my electrons in this case is being added. I can see that there's a negative charge now on the chloride. Again, I need to balance it. So there's 2 chlorine atoms here, 2 chloride ions here. So I need a 2 in front in order to balance that out. In fact, I'm just going to move the product and reactant. Reactant, product. There we go. And then what I'm going to do is I'm going to put the full equation together. I'm checking to see if my electron numbers match, and they do. So I can automatically cancel them out, and I can just rewrite the final equation. So magnesium plus chlorine makes the magnesium 2 ion plus the 2 chloride ions. So hopefully that keeps it kind of nice and simple for you guys to think about when you are looking at it. I'll do a couple more examples just to kind of make sure you guys understand what's going on. So in this example here, I have iron going to iron 3. So in this case, I'm becoming a positive ion, so I must be losing electrons. And since it's a positive 3 now, I must have lost 3 electrons. For the copper, I see that's a positive 1 charge, and now it's going to the copper element, so I must have gained an electron to do that, and in this case, there's only 1 electron gained because it's positive 1 to having no charge. So that reaction's already balanced for me. Now let's see how I put it together. I need these electron numbers to match, and currently they don't. This one is 1, this one is 3. So what you then do in this case is you're going to multiply the whole equation by 3, so that way these electron numbers match. So since I'm multiplying the whole equation by 3, a 3 goes in front of that copper 1 ion, a 3 goes in front of the electron, and a 3 goes in front for the copper metal. So that way these electron numbers now cancel, and I can write my final equation down. And like I said, you can see how having the arrows lined up makes it really easy for me to see the electrons and to make sure they're on opposite sides, make sure that those numbers match and cancel out. There isn't any rules to how you order these elements in the equation. I mean, I could have swapped it around and done, you know, the copper first and then the iron. It's all the same thing. The only thing that's important is that you have them on the right side of the equation. So either one is fine. Let's erase it because I don't think that's terribly important. All right. Next one here that I'm looking at, I have silver, and it's going to the metal. That's a positive 1 ion, and now I've lost it, so I must have gained an electron. That equation's just fine. This one here, copper, I see it's now form a positive 2 ion, so I must have lost 2 electrons in that process. Again, check the electron numbers, and they don't match, so I'm multiplying this whole thing by 2. So the 2's will now cancel out, and I can write my final equation. Now, what I should also note is just helping you guys with the vocabulary. This whole thing was multiplied by 2. go. Arrow, 2Ag plus 2A plus. Cool. Or maybe I should do that. No, I'll do it now. All right. Some things I just want to note as a reminder of vocabulary. Looking at where those electrons are, you can tell oxidation and reduction. So this equation here, I see the electrons are on the product side, so that's oxidation. Oops, let me spell oxidation right. I see that it's gained electrons, so that one's my reduction. And then if I was to identify things, this here is going to be my reductant, and that's going to be my oxidant. Do some more examples. Again, my electrons are on my product side, so it's lost those electrons. Remember, think Leo the lion says grr. Loss of electrons, that is oxidation. This one here has gained 3 electrons, so that's my reduction. And then when I go to name it, that's my reductant. And that is my oxidant. Cool. All right, last one here. I see my electrons on my reactant side, and the silver ion has gained it. So that's my reduction reaction. In this case, copper has the electrons on the product side, so it's lost those 2 electrons, so that's my oxidation reaction. But remember that vocabulary switches when I'm talking about it. So even though this is a reduction reaction, the silver ion is my oxidant. And then my copper is my reductant. Cool. Something I do want to point out to you guys is just keep in mind that something can be a reductant in one reaction and an oxidant in the other. And remember, whenever you're looking at the terms oxidant and reductant, we're referring to the reactants. All right, let's do the last one. So here's my oxygen gas. It's gaining electrons to form the oxide. Now, the first thing I have to keep in mind here is that the oxygens are not balanced. There's a 2 here. There's only 1 oxide, so I'm putting a 2 in front. The next thing I need to think about then is the number of electrons I should have. So this oxide has gained 2 electrons, but I have to remember there are 2 oxides. There are 2 oxygens on this side, so each oxygen has gained 2. So 2 times 2 is actually 4 electrons that I'm working with. Since this guy has gained electrons, this is going to be my reduction reaction. All right, looking at my zinc, zinc has become the zinc ion, and I notice that it is now +2. So it must have lost 2 electrons in that process to do that. Losing of electrons, Leo says grr, so that's my oxidation reaction. Now, once again, I need to check my electron numbers to see if they match. That is a 2, and that is a 4. So this whole equation is going to get multiplied by 2. So when it's been multiplied by 2, zinc becomes 2, zinc ion becomes 2, and that becomes now 4 electrons. So when I look, these electron numbers match. That can cancel out, and I can write my final equation. So I have oxygen plus my zinc. I might actually draw that 2 a little differently so we know it's not ZZ. There you go. And then it's forming 2 oxides and 2 zinc ions. So that's my equation. And again, using my vocabulary, I see that this up here is my reduction reaction. So this makes oxygen the oxidant. And zinc has been oxidized, so that makes that the reductant because it's reducing the oxygen gas. Cool. All right, hopefully that makes sense to you guys. I'm hoping with multiple examples, you guys will get it. There's plenty of practice problems as well, so hopefully with a combination of those things, you'll be able to understand this material. Alrighty, so here is the vocabulary summary, basically kind of showing you how to write sentences and how to kind of pick your different words using the example that we talked about previously. So you can say magnesium was oxidized by the hydrogen ion to form the magnesium 2+ ion. You can refer to magnesium as the reductant, or you can also say that magnesium reduces the hydrogen ion. All those are correct terminology. With the reduction, you could say hydrogen ion was reduced by the magnesium to form the hydrogen gas. Hydrogen ion is an oxidant. Hydrogen ion oxidized magnesium. All of those sentences are correct. Just be really careful about which vocabulary you're grabbing, because it really is supposed to describe what's going on. But don't worry, you'll be using multiple kind of layers to answer and equations to help show what you know and communicate it across. All right, Kapai, really good work today. I know this lesson's probably a bit longer than the others, but hopefully by the end of it, you guys should be able to define that key vocabulary for redox and be able to do the simple redox equations. Follow-up work for today's lesson, I want you guys to do the work for lesson number 1. It is differentiated, so pick any of those items to do. You don't need to do all of them. Just do what you need to do to feel confident with this material, and please do keep a track record of the evidence in that Google Doc with the week 6 lockdown work. If you're in my class, can you please do your week 6 reflection? I feel like this is a really great way for us to keep connected to each other. State your micro goal, summarize what you learned last week in chemistry. If there's anything you want to share with me, you can. Don't feel like you need to if you don't. And then here is our random weekly question. It's more of an opinion-based question. And it's, do you think burgers are considered a sandwich? And I want you to defend your choice. I just figured that's a little bit fun. Anyway, that's everything for this first lesson.